Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing cutting of a spring. Suppose a spring of spring constant K and length L it is there, and if you are cutting, okay, then what will happen? Now here spring constant will change. So that one will try to understand how to find a spring constant for that particular spring. Okay. So here we have a spring with a spring constant K and a length is how much? L. So this is called a length of the spring. This is the length of the spring and this is your spring constant. And remember, spring constant always depends on the material. So material of the spring. So here spring constant K, length L is there. Now suppose you are cutting two parts. Suppose here the same spring you are cutting. Okay, you can cut any arbitrarily. You can cut here. Suppose you are cutting from here, and here to your length is L1 and here to your length is L2. Okay. Suppose you are cutting like that part. So here this length is coming L1 and here this length is coming how much? L2. So if you do that, then what will happen? Now the spring constant K will change for this spring also, this spring also. So it will be different. So for this spring I can write it is suppose K1, for this one it is K2. Okay. So I have a one spring is cut into two parts L1 and L2. One part is K1, one part length is having L1 and spring constant K1, another part is length L2, spring constant K2. Now we need to find what is this K1 in terms of this K, what is this K2 in terms of this K. Okay. So this is what we need to find actually. And also we need to understand, if length you are cutting, then what is the ratio of this length, or like how you are cutting, okay, equally cutting, or it is L by 3 and it is 12 by 3, like that one you are cutting. So that type of things basically we will see. So here suppose I am taking cutting ratio. Suppose here when I am cutting this is the position where I am cutting this length L1, length L2 coming, and I am writing here cutting ratio how much? Cutting ratio, that means L1 by L2 is nothing but that is M by N. So M is to N cutting I am doing N. So this ratio cutting, it can be half, this ratio can be half, this ratio can be 1, okay, this ratio can 2 by 3, whatever you can get, this ratio up number is M, down number is N. Okay. Now here listen, this L is how much? This L is nothing but that is L1 plus L2, L1 plus L2. So that means whatever the total length is nothing but it will be L1 plus L2, and here we know what? Here L1 by L2 is nothing but M by N. So L equal to L1 plus L2 and L1 by L2 equal to what? M by N. L1 by L2 equal to M by N. So this is the two relation coming, and from this two relation we need to find what is my L1 in terms of M, N and L, and what is my L2 in terms of M, N and L. So here this we need to find. So how to find that? Now if L1 you want to write, see here L1 you want to write, that can be written as L minus L2, or L2 if you want to write, I can write L minus L1. Okay. So simple thing, if L1 I want to write L minus L2, L2 I am write L minus L1. Now here L equal L you keep L minus, if L2 you want to write, see here L2 if I will calculate is N times L1 by M. So in place of L2 N times L1 by M, and here I can write, this implies, here see, so here L1 is there and here one L1 is there. So this one I can take right hand side, this one I can take left hand side. So it will be L1 plus N L1 by M equal to L. Now see here, so if I will calculate this one, here L1 I can take common, I can write it is M plus N by M, that is equal to L. Now from here if I want to find L1, how much I can get? ML by M plus N. So my L1 is coming how much? Now L1 is coming M times L divided by M plus N. Okay. And Mn is what? Now L1 by L2 ratio is nothing but M by N. Now understand here. Now here if you calculate similar way, if you put L1 from here, you will take L1, that is how much? M times L2 by N, then definitely I will get how much? N times L by M plus N, N times L by m plus n. So, this is my L1 in terms of L, this is my L2 in terms of L. So, once I am getting this from this two equation, then I can go and I can calculate what is K1 and K2 in terms of the spring constant K. So, this is what our motive to calculate. Now, understand if these two springs are connected in series. Connected series means if these two end I am joining, then what will happen? Now, this will look like this spring, exactly the length will be same and spring constant will become also same. That means what I am telling, if you connected in series, then here whatever force you are giving here, force F, the same force also will be here F1, same force also will be here F2 if they are connected in series. Connected series means this end, suppose this is the left side, this is the left side, this is the right side, this is the left side, this is the right side, this left right connection will be there, that is called series connection. If left connection is there, right connection is there, then it is parallel connection. If left right connection will be there, here left, here right, and that is called series connection, connected in series. Then what will happen? In series, remember always for spring case, so force remains constant in series. Okay, that means if two springs I am telling like this, these two springs are there. So here spring constant K1, K2. If I am giving a force here F, okay, then this force remains same for this also, same for this also. Force basically you can understand like a tension. Okay, okay. So in series connection, remember force remains same. Now here I can write that F is nothing but how much? Now here we have from the simple harmonic condition F equal to basically minus Kx. Okay, or you can write this one as basically what magnitude wise F equal to nothing but F equal to K times X. K times X. So force is basically restoring force. You can tell that restoring force is spring constant times length. So here in this spring if I want to write, that is how much? F will be nothing but K times L, and this F will be nothing but that is equal to F1, that will be K1 times L1, and F2 that is also K2 times L2, and here this all will be equal. Because I told if this you are combining like this, then what will happen? It will get this type of spring, and here K times L is equal to how much? K1 times L1 and K2 times L2. Now here I can write what? KL equal to K1 L1 equal to K2 L2. So this is what condition, remember. So one equation, two equation, this is the third equation. These three important equation we need, and from here you can find K1, and from here you can find what is K2. Okay. Now see here K1 is related to KL and L1 also, and K2 also related to KL and L2 also. And already I got what is my L1 and L2. If I substitute that, then I will get the K1 and K2 value. After finding that, I can take some simplified cases like suppose L1 and L2 are equal parts. That means these are equal, then this ratio will become 1. That means M is equal to N. So if that condition will put, we will get what is your K1 value, what is your K2 value. So similarly, some other cases also you can see. And also if you are cutting not only 2, we are cutting 3 parts also you can solve, but mostly understand for 2 parts, and for 3 parts some MCQ question will do. On that we will try to understand how to do for 3 parts. Okay. Now here see, so KL equal to K1 L1 equal to K2 L2. Now understand here, so here your K1 if you want to find, it is KL by L1, and if you see this expression, here L is there, L1 is there. If L1 I take that side, it will become L by L1. If L1 I will take right hand side, it will become L by L1. If M plus N I will take left hand side and M I will take down, then I can get the value of L by L1. So L by L1 how much? M plus N by M. So my K1 value is nothing but M plus N by M, M plus N by M into K. Similarly, my K2 value will be KL by L2, that is nothing but K into M plus N by N, or I can write as M plus N by N into K. So this is what I am getting. So my K1 and K2 I am getting from L1 and L2 ratio here given. So, here you will find L by L2, then it will be m plus n by n, m plus n by n. Okay. So, here this is the K1, K2 you are getting. Now, we understand if this spring is caught into equal part, what happens? If spring is caught into 1:2 ratio, what happens? If spring is caught into 1:4 ratio, what happens? Like that one, we will try to understand. Okay. Now, you see here, suppose here I am telling my L1 by L2 ratio is nothing but that is 1. So, 1 means m by n also 1, that means this implies what? M equal to n. So, here if you substitute m equal to n, then my K1 how much? So, here it will be 2m, suppose you take m equal to n means n, in place of n you take m, 2m by m into k, that means how much coming? 2k. Similarly, K2 if you want to calculate, so take here 2n by n into k, that is here 2k. So, that means what happening? N will get cancelled, here m getting cancelled. Remember, in place of m you are taking here n, because m equal to n for this case. So, L by L1 by L2 equal means what? Now, here cutting is half. Okay. So, equal part cutting. So, you are cutting one spring in equal part, then what will happen? L1 by L2 is nothing but 1, because this will be same equal part, length will be equal. So, m by n you are getting this much, and K1 is 2k and K2 is 2k. Okay. So, here another thing also you can understand. Suppose I have a spring of a length L, if I am cutting to L by 2 part and L by 2 part, then this spring constant will become 2k, this spring constant will become 2k if this spring constant is initially given k. So, that means if length is decreasing by 2, spring constant is increasing by 2. Okay. Why it is happening? Now, because you know F equal to kx, or you can write basically kl, and here from here I can write k equal to nothing but f by l, or you can write k is inversely proportional to length. So, that means if length increases by n times, k will decrease by n times, and if length is decreases by n times, k will increases by n times. Okay. So, remember, so inversely proportional, if length decrease by n times, k will increase by what? N times. But depends if you are doing basically this type of diagram and you are understanding perfectly what is happening. So, remember, when you are cutting the spring, length is reducing and spring constant is increasing, So, this is one formula you remember for two types, two spring is there and you are cutting them. Okay. Now, suppose I will tell this L1 by L2 is nothing but 2:3 cutting. So, about 2:3 cutting, then what will happen here? M value will become 2 and N value 3. Now, if you want to find K1, how much I will do here? For finding K1, I have to write what formula? M plus N. Okay, spring constant, initially suppose spring constant is K given, and here what is this? Now, M plus N by M into K. So, K1 will become 2 plus 3 by M is 2 into K. So, first part will become this much, okay, because your first part is nothing but 2 ratio cutting. So, now it is how much? 5 by 2 K, and K2 is nothing but that is your M plus N 2 plus 3 by 3 K, which is nothing but 5 by 3 K. Okay. So, this is your idea you are understanding here. So, if L1 by L2 ratio is 2 by 3, okay, that M is 2 and N is 3, then you can cut like this. Okay, you can cut like this. So, this is the idea you must understand here. Now, next we will be solving some questions based on this spring cutting, and we will try to understand there also. Okay, so for 3 type of cutting, that means one spring, but you are cutting in the ratio 1:2:3. Okay. Now, see here something when calculating this one, you are taking some what M plus N by N and M plus N by M, like that type of things you are taking for 2 springs, remember. Now, for 3 spring we will do in questions itself. Now, here see the question is telling a spring of a force constant K is got into length ratio 1:2:3. Now, they are connected in series and the new force constant is K prime, and then they are connected in parallel, and force constant is K double prime. Okay. So, first of all here 3 concept at a time is there. So, first thing is you are cutting the spring, second thing is spring are connected in series, and third thing is springs are connected in parallel. Then after you have to find some ratio and all. Okay. So, first thing remember we will find the cutting of the spring, then after we will see series connection what happens, then we will see in parallel connection what happens, then after we will try to calculate here. Okay. So, these 3 things we need to at a time we need to put it here, and here not a 2 spring, here it is 3 spring. So, that m is to n formula is for 2 spring, but here I will tell how to solve this also. Okay. Now, listen here. So, the thing is basically here cutting you will check. So, they are telling one length is there, one length is there, one length L, spring constant K, spring constant K. Now, what is happening? Now, this length is cut into ratio 1:2:3 ratio. So, here one spring constant will come, suppose K1, here it is K2, here it is K3. Okay. Now, how to find this K1, K2, K3? Now, they are telling this ratio cutting is how much? 1:2:3, 1:2:3. Okay. Now, what you do? So, now you find what is this length L1. Now, you just add these numbers. How much? 1 plus 2 plus 3, that is basically 6. So, tell this one suppose it is L by 6. If it is L by 6, they are telling 1:2:3 ratio, then L2 will be definitely 2L by 6, and you can tell L3 equal to nothing but 3L by 6. Okay. So, here you see if you will add this length, definitely we will get length is how much? L. Okay. So, L plus 6 plus 2L by 6 plus 3L by 6. So, how much you will get? You will get basically L. That means you are understanding here L1 has decreased by 6. That means length decreased by 6 means your spring constant will increase by 6, and here 2L by 6 is nothing but L by 3. If L2 decreases by 3, spring constant increases by 3. Now, here it is L3 decreases by 2 means spring constant will increases by 2. Okay. So, this is the idea to understand. Your L2 is decreasing by 3 means K2 will increase by 3 times. If L3 is decreasing by 2, because 3 will cancel 6 as 2, 2 will cancel 6 as 3. So, it will be L by 3 coming now. So, that is why K2 is increasing 3 times, K3 is increasing 2 times, but this K1 is increasing 6 times because it is L by 6 is there. Okay. Now, understand why I took L by 6, 12 by 6, 3L by 6. I did not take I can take it is L, 2L, 3L like that we can take, that ratio also coming 1:2:3. No, I cannot take that because this total length is L. If I will take each, this is L, this is 2L, this is 3L, then total will come 6L. So, length will be increase, but I do not want that because I have only length L. So, that is why I have to plan in such a that okay, I should get this addition length total should give me L, and the ratio should be also 1:2:3. So, the thing is basically you take this LCM or add this 1 plus 2 plus 3, then after you calculate okay, the ratios. Now, after getting K1, K2, K3, now come to series connection. So, for each spring we got what is my K1, K2, K3. Now, we will understand series connection, then we will understand parallel connection. Remember, here I will tell if springs are in series, then here we will do reciprocal addition. Springs are in series. If there are many springs in series, then what we will do? Now, we will do 1 by K equivalent equal to 1 by K1 plus 1 by K2 plus 1 by K3. Okay. Now, here if there are many springs are there, you can take like this type of things, like you can add, keep on adding on that. Okay. So, for 3 spring you could do like this. If 2 springs is there, suppose 1 by K equivalent, for 2 spring what will write? 1 by K1 plus 1 by K2. If 4 springs are there, then similarly 1 by K1 plus 1 by K2 plus 1 by K3 plus 1 by K4. Okay. But remember, for 2 spring you can use this formula, or you can use, if you will calculate from here, I will get K1 into K2 divided by K1 plus K2. Okay. Remember, when springs are in series, for 2 spring you use this formula, multiply the spring constant value divided by addition of the spring constant value. If 3 springs there, you calculate this, it will be better. Okay, no need to do any LCM and all. You can calculate LCM, but direct use this formula. So here 1 by K equivalent. Now check what is the spring constant given here? 6K, 3K, 2K. So I can write here 1 by 6K plus 1 by 3K plus 1 by 2K. And if you calculate this one, so how much will come? Now LCM will take basically 6K. So it will become 1K plus 2K plus this will become again 3K. Sorry, I think it will become, if LCM will take, it will become 1 plus 2 plus 3, which is basically 6 by 6K. So 1 by K equivalent coming 6 by 6K, or you can write K equivalent equal to 6 by 6 is cancelling. So it is becoming K. Okay, 6 will get cancelled. So that means what you are understanding. Now if you will add this spring constant in series, definitely you will get how much? Your spring constant will get K. Now that is what basically they are giving K prime. So that means you got your K prime is nothing but how much? K prime is nothing but K. Now you need to find what is your K double prime. What is your K double prime? What is K double prime? Now K double prime is nothing but they are telling it is your when springs are connected in parallel. So this parallel you will understand here. Okay, now remember, if springs are connected in parallel, so here I am telling, if springs are connected in parallel, there are many springs are there and they are connected in parallel. Springs connected in parallel, then K equivalent, that means equivalent spring constant is nothing but K1 plus K2 plus K3. If 3 springs are there, I will write up to 3. If many springs are there, I have to keep on adding. I will keep on adding. Now what is K equivalent? Now K equivalent is nothing but it is just 6K plus 3K plus 2K. So how much coming total? It is coming 11K. Okay, 639 to 11. So K equivalent is coming 11K for this particular question, because they are given K1 6, K2 3K and K3 2K. So that means I can write here it is 11K. Now K cancel, how much I am getting answer? 1 by 11. So your answer will be what? B answer, which is 1:11. 1:11. Okay, so this is a NEET previous year question in 2017. They asked this question. So here you understand that whenever 3 type of springs are there, then first you find what is the length cutting, like what is the length ratio and all coming. From length ratio try to find what is in fraction, then after try to see what is K1 coming. Okay, K1 is increasing or decreasing, like that you check. After that you find if they are given in series or parallel, you accordingly you solve. Okay, and remember in series connection what do you have to do? Series connection, series means this type of connections are called series connections. Okay, so springs are in series, left right connection is there. But parallel means what? Parallel means this type of connection. So here left right. So you can understand left connected to one point, that means one wall, and right connected to other part. Okay, other part of a mass also they can connect, no issues. So this type of thing is called basically parallel connection. Okay, and this type of connection is called basically series connection. In another video we will be discussing what is series connection, parallel connection, along with some problems. Okay, so I hope this question you understand carefully based on the cutting on the spring. If any ratio they are cutting by taking 2 springs also, by taking 3 springs also, I hope you can calculate. Thanks for watching the video. Like and subscribe Vidhyalakshmi NEET Academy YouTube channel. Thank you very much. All the very best.